Perfect. Thank you. So yes, that's what we're doing today. So first off, as she pointed out, you can still NGR today. What that means is if you are feeling like, oh my gosh, I'm not ready for this, I'm completely unprepared for this class, I don't know what I've been doing, and whatever, I can still drop you today, and it will be as if you never took the class. Like you'll get your money back for the tuition. It will not count as one. It will not show up on your transcript at all, and you will. It won't be one. It won't count as one of your attempts. So if you want to do that today, today is my last day. I guess they gave us till today. I didn't realize. I thought we only had till Sunday, but we have till today. I can do that. Just stick around before you go to your breakout room and just let me know, or before class is over, just kind of hang out and just let me know that you want me to do that, and I can do that for you. If you decide to stay, and exam one does not go well on Thursday, then just be resilient, keep working at it. You'll just work hard. Chapters 3, 5, and 6 don't have a whole lot to do with chapters 1, 2, and 4. But after that, it starts building. So like chapter 3 builds on to chapter 6, and chapter 6 is really critical for chapters 7, 8, and 9. So, after this exam, then all of a sudden it's really important. Everything builds on each other. You've got to really understand and have a good, solid foundation after that. So if it doesn't go well, then you just have to work really hard and make sure you stay focused and really stay on top of all this. We're going to go over chapter 4.4 today. That's what we're doing, kind of reviewing that one, and then a little bit of exam review in general. You have Connect Math chapter 4.4 due today, and also next Thursday, Excel Lab 4. I am not going to have you do all the pieces. I have to figure out exactly which piece I'm not going to have you do. I'm not exactly 100% certain of that, but I will know after this weekend, or during this weekend at some point. I'll get that sorted out. And then again, the review tomorrow on Zoom. I will record those and post those. So if you can't make it, you can watch the recording. There's 2 sessions, and it's not our usual Zoom. It's my Monday, Wednesday Zoom, so it's a different Zoom number. Okay, it's in the email and in the announcements. All right, so exam 1. How about Carla? Go ahead and read for us.
Chapters 1, 2, and 4. You study guide for topics covered. Bring pencil, a half page, one-sided notes, must be handwritten. Graph paper, basic calculator, still a half to write formulas for 4.4. No cell phones, and extra credit for sports.
Great, thank you. Yes, it's going to be in Canvas, so be prepared to take it in Canvas. It's going to have a half-page, one-sided of handwritten notes, and you can have a calculator. I don't care what kind of calculator, because no matter what, you still have to write your formulas out for 4.4. Here's more information on exam 1. How about Eddie? Can you go and read it for us?
You may take it at 2, 5, or 7:30 on September 17th, but it must be at one of these times, give or take 15 minutes. Let me know if you are taking it at a different time than your class. Do the practice test for 1 exam point in Canvas under quizzes, which must be done in the Chrome browser. You also need a webcam. If you do not have a webcam, email me for an alternate test and what time you want to do it so you can zoom in on your phone with me. You must take this practice exam by September 16th. If you do not, and then cannot get Proctorio working correctly, then you will have to take a 0 on the exam. If using attached webcam, make a platform, use books.
Great, exactly. So the practice test, so Proctorio tells you that you're supposed to have the camera on your face. That's not actually true. I don't want it on your face. I want it, when I look at the videotape, if I look at it, I want it to be on your hands. I want to see your hands and what your hands are doing. Right, so that's what I need. It's a little bit different than, let me show you what I'm talking about. Oh, hang on, let me get here. All right, so here's your laptop. tilt it down so that it's, angled towards your hands. Oh. Elias, don't grab my signal here. So that way I can see it's tilted downwards and you can see your hands. In order to be able to see your screen, what some people are doing is they've taken a couple of textbooks and they stick it under your, guys keep grabbing my screen from me. You stick it underneath their laptop and they bump it up higher so then they can see it better. They have a better angle to see it. The other thing is when you're inputting information, feel free to tilt it up, right? Type in your stuff and then tilt it back down again. That's totally fine. I'm okay with you guys doing that. If you need to do that in order to input your answers and things like that. That's totally okay. If you tilt it up for a few seconds, put in your answers and then tilt it back down again, 30 seconds, no big deal. Okay? Questions about that?
Yeah, I have a question, Professor.
Yeah, go ahead.
I have a Surface Pro, and my computer has a leg to keep the computer screen up, so I have a difficult time trying to point it down like you're instructing us. Right.
So what you probably want to do is when you get it, what you want to do is probably honestly lay it flat and maybe slightly tilted up. So so what some people have done is they've done this kind of interesting thing where they'll take a tablet, right, and then they have some sort of stack of stuff, and then they put what I saw was they put canned food on top to weight it up here, so they had it sort of sandwiched here, so then the camera's facing straight down on what they're working on. Does that make sense?
Okay. I'll try my best to get it.
Yeah, so that's what a lot of instructors are using as kind of as docked cameras, right? They've taken their tablet computer and they have it on a stack on a box or whatever, and then they put something heavy. I think the thing that I saw was they put cans of food on top, but you can put textbooks or whatever to weigh your surface so it doesn't flop over, and then your surface can be pointed straight down on your working area, and you can get it to see what you're doing. That makes any sense. The thing is, it's going to be really hard though, because then you have to try to input it. So that might make that a little bit harder to do. I don't know. Let me think about that. I haven't had that. Is there any? So what you can do, maybe you consider that as well, is maybe what you do is we consider those situations where you end up Zooming with me on your phone. So Trevor mentions also, and if you can't get Proctorio working, then I can have a few people, because I can watch a few people. They can be Zooming with me on their phone, and then taking the test on the computer. So that could work as well.
Okay.
Yeah. So that might be what we need to do. So see what you can do it going, and if you can't get it to go, then we'll need to do that instead. All right.
Sounds good.
Good. But I do need to know ahead of time, because I need to set that up for you. So email me if you need to be in that situation. If Proctorio is just not working at all for you, then we can work it out. You're Zooming in person with me while you do it.
I'm going to try to figure that out tonight, and if I have any other problems or questions, I will email you. Okay. Sounds good. Perfect. Great. So who was that, by the way? Eddie.
Okay, good. Great.
Professor,
Yeah.
Just to not disregarding the test though, just the Excel lab, that's due next Thursday, you said?
Yes.
Okay.
A week from Thursday, yeah.
Okay.
Yeah.
Thank you.
Yeah, that's Excel Lab 4. Yeah. 3 we'll do afterwards, where we're doing Chapter 3, which will be in a couple of weeks. We'll get to Chapter 3. So we're going to go 1, 2, 4, then 3.
Oh, okay. Thank you.
You're welcome. So yeah, practice test for exam 1, you need to get that done. Make sure you get that done. So the practice test is, if you go to our class, go to quizzes. Oops, wrong class. Go to quizzes. You'll see there's exam 1. take it. Right? It's pretty straightforward. There's some instructions. You have to be doing it in Chrome. You cannot do it in Firefox like I'm trying to do it. You have to do it in Chrome. There's a Proctorio add-in that you have to download and enable, and then you can use Proctorio to do it. And then make sure that you, like I said, your practice tilting. It's going to ask you to have your head in the picture. After you do that, just go ahead and tilt it and not have I want your hands on there, because like I said, I've had students who work so hard and don't pass the class, and then if students cheat and pass, it's just so not fair to the people who worked their butts off and didn't make it. So I can't. Life should be at least reasonably fair as much as we can be. All right, so in here there'll be blanks that you fill in. Right, fill in your blanks. Make sure you fill in the blanks. If you leave these blank, then you're going to get a 0 on those problems. You have to fill in your answers here. And then also write down your answers and show your work. You know, there'll be definitely some things like with trees and things like that, because then you're going to go to assignments and you're going to upload it right here. Exam 1, Part 1, upload. You'll have 5 minutes. If it takes you a few more minutes, it's fine, but roughly 5 minutes after your exam is over, after you submit your exam, because I can see when you submit it, to scan your pages with your phone, take pictures of them, save them as one PDF, and upload them. Okay, good. Zachary, go ahead and read for us.
Exam 1. Exam 1 will cover chapters 1, 2, 4. The study guide is in Canvas. Under study guides, you also need your calculator. Was that read already? No? Okay. I shall continue. You also need your calculator, half page of handwritten notes, and 8 blank papers. If you're taking the exam at a different time, please write that at the top of your first blank paper. Example 5 o'clock class, taking it at 2. Once you start the exam, you'll have 5 minutes to scan the area in front of you, your working area, and get your camera positioned so that it shows your hands. If using a webcam attached to your computer, I suggest maybe making a raised working area by putting a couple of large books down. They should be closed, not open to it.
Great. So it's similar but slightly different. Great. And then, so that's it on the exams. Hopefully people don't have any other questions besides that, about that. Okay, counting rules. So the fundamental principle of counting is when you take the total number of possible outcomes for a series of decisions, and you get that by multiplying the number of choices for each decision. So in other words, how many decisions am I making here? I'm choosing pants, that's one decision. I'm choosing a shirt, that's the second one. Shoes, it's the third one. Socks, the fourth one. So there's 4 decisions I'm making. It's 4 things that I'm multiplying. So ideally, I would like you to get in the habit of, when you do this, write down a line for every single decision you're making. 4 decisions, I'm going to multiply these, and then figure out how many choices for each decision. For the first one, 2 pants. Next one, 3 shirts. Next one, 5 shoes, 4 socks. This will work anytime for any sort of counting, how many combinations, how many possible whatevers, how many ways. That will work for anything except for combinations, except for, when order doesn't matter. That's, which is that one special case. But here it's like, this one we have 4 different categories. I'm choosing one from each category, so that's pretty straightforward, right? 4 times 3 times 5 times 4. I feel like you guys are pretty okay with this one. We'll take a look. Why is it not working? Quiz problem number 3. All right, so let's take a look. So here, go ahead, interesting answers for this. Right, very few people got this right. Okay. Yeah, I wouldn't have trouble with this one. All right, so I guess my question is, only one group, and then the group that they worked with. Oh, two groups, a couple groups. All right, so here, let's pick one that somebody who had trouble with this one. We'll start off there. All right. So first off, how many choices am I making? I'm picking, how many letters am I going to have?
We said 26.
Okay, there's 26 letters in the alphabet. Yes. And how many choices am I making? How many things am I picking? How many things am I picking?
4.
4. I'm picking 4. So you're going to have 4 things here. Think of it that way. It's the first thing you should do. I'm picking 4 items. I should make 4 things here. How many options are there for the first letter? For the first option. How many options do I have? First letter must be what? Carry W. How many choices do I have then?
2.
2. Great. Now I've picked it. Repetitions are not allowed. So how many options? I can pick any letter except for whatever I picked first. I can't repeat letters. How many options for the second spot?
1.
Only one letter? There's only one choice?
It's 25 letters.
There's 26 letters in the alphabet. I've picked 1. How many are left?
25.
25. If I pick the K, it's every letter except for the K. If I pick the W, it's every letter except for the W. There's 25 left. Does that make sense for folks?
Did it have anything to do with factorial? I'm sorry.
Nope, it did not.
Okay.
This is a fundamental counting principle. So that's why we're going over this. You guys can tell the difference between them. You can figure out how they differ, how they're not the same.
Okay.
So, so then, after that, how many options for the next spot?
24.
24. And the next spot, 23. If you did it wrong, then doggone it, write it down and fix it. That's fine. No worries. But don't leave it wrong, because that's no good.
Wouldn't it be like 24, 23, 22?
No, because you can use, if I have K, I can use W. Does that make sense?
Yeah.
So I have 25 options here.
So, but if we did it as, when I did it as, like set it up as 2 permutations, I got the same answer. Would that be? You did 2P1. Yes, and then
times
a 25P3.
Oh yeah, you can do it that way. You can do it that way.
Thank you.
Who did it that way?
Thank you. Okay, Jamila.
Okay. Yeah,
Thank you.
that's unique. You could do it that way. That's yeah, you could do it that way.
It's the same answer.
Yes.
Thank you.
Yeah, I think it's a lot more complicated, but yes, you could totally do it that way. Absolutely. There's multiple ways of getting there. That is a different way. Oh yeah. That's interesting. That's good. All right. So next we have this factorial, right? Factorial is when you multiply. You start with a number, you multiply all the positive numbers from 1 up to that number and including that number. So it's 3 factorial is every number multiplied from 1 to 3. That's the number of ways of arranging 3 items. Because how many options for your first spot? 3. If you take that one and you can't reuse it, right? You can't put it in 2 different places. Then how many options for your second? 2. How many options for your last one? Just 1. So it's the number of ways of n factorial is a number of ways of arranging n items. Quiz 2 is all about that. Let's see. So there we go. 9 factorial. This is absolutely correct. Now here's the thing. I want you guys to show me that you know what it means. So on your exam, you would get, out of 4 points, you might get 2, maybe 2.5. I might give you 2.5. But you need to show me this times that times this. You need to prove to me you know what 9 factorial means. Does that make sense? If you do this, then you will get full credit. I need to see exactly what you're multiplying and dividing and all that stuff.
quick question, Spivey.
Go ahead.
If I wrote it out like that on the quiz, but if you don't put the 9 factorial in front of it, that's you're gonna get some points.
I don't need this. I do need this. If you just gave me this, you'd be fine.
Alright, sweet, thank you.
Yeah. Good question. Okay, great. Brenda, go ahead and read for us.
Okay. Permutation is a selection of objects that cannot be reused. Order matters. Start from n and multiply r consecutive, decreasing numbers. If we only care about the top 3 finishers, how many possible finishes are there? For a race, if there are 8 total horses.
Perfect. Thank you.
8. Okay.
That's good. No, that's perfect. Right. So permutation is when permutations and combinations are when you pick. You have this sort of one pool of options that you're choosing from, and you cannot reuse them. It's a special situation when you have a pool of options, objects that you're picking from, and you can't reuse those items. And order matters. So permutations and combinations are when you have this pool of objects. When order matters, it's a permutation. When order doesn't matter, it's what we call a combination. So the easiest way to do permutations is really, honestly, it's just a fundamental accounting principle. How many options am I picking? I'm making R decisions. So I'm going to draw R different spots. So like here for the top 3 finishers. There we go. I'm picking 3 spots. I'm going to draw 3 lines. My options for the first one, 8. My options for the second, 7. Next one, 6. Done, that's it. Don't make it more complicated than it is. Yes, there are formulas the book has taught you. I think they're more confusing because they're hard for people to understand and explain. It's just another thing for you to memorize. And math is not about memorizing, right? If we're just about you memorizing stuff, then why wouldn't we just do a spelling bee? Why wouldn't we just do a spelling bee? And the whole idea of it is for you to understand and figure out things. That's a useful skill. That's a skill that we're trying to teach you in math so that you can apply it to life, right? Memorizing formulas and plugging stuff in is not that. All right, so this is a permutation. Again, I like to think of it as like, this is how many spots you have. Start with for the top one, you multiply down that many spots, right? You subtract 1 each time. You have 1 less each time. So for you folks, let's see, that was this problem here. So someone from group 6, all right, so this one, how many ways can you arrange letters in the word decagon? So there's 7 of them. Arranging means you're going to use all of them. So it's just 7 factorial. And see how they spelled it all out? That's great. How many different 4-letter permutations can be made from the letters not reusing letters? Again, you cannot just do this. You'll lose half the credit if you just give me the answer like that. You have to show me what you did. So here, this is kind of okay. They broke it down to 7 factorial and gave me that over 7 minus 4 factorial, but that's not 7 minus 4. Is it really 7 minus 4 factorial?
Yeah, because R equals 4.
But that'd be, 3 factorial. 3 times, yeah. So you could do it that way. That would probably be, this would be the bare minimum you'd need to show me in order to get full credit for this. And then let's take a look and see what other people have got. Let's see if anybody wrote it out. Yeah, and see this would also get full credit. What if you could reuse letters? Aha! Now a lot of you guys missed this one, so again, fix it. If you can reuse letters, then you're having 4 slots. Some of you guys might have did 7. If you did 7 slots, that's fine. If you read it as 7 letters. How many options for the first one? 7. Next one 7. Next one 7. Next one 7. So 7 times 7 times 7 times 7, 2401. Again, if you read it as being 7 letters, then and you'd have 7 of these, that's fine as well. Fix it if you did it wrong. Make sure you have this fixed. Okay, so that's kind of the simpler stuff. Now we're going to get into the more complicated things. what if order matters? Okay, so if we are picking 3 people out of 4, if order matters, then there's 24 different possibilities. Here are all 24. What we learned was if order doesn't matter, then all of a sudden this just becomes, these all count as the same as one group. This all counts as 1. This all counts as 1, and this all counts as 1. So there's only 4. Why am I dividing by 6 to get from 24 to 4? I divide by 6. Why 6? Because there's 6 items here that would all be counted as the same if order doesn't matter. Why are there 6 of them? Because that's the number of ways of taking 3 people and rearranging them. How many ways can you have 3 people and rearrange them? Well, 3 options for the first one, 2 options for the second spot, 1 option for the last one. That's 3 factorial, right? So that's why you divide by. I like to think about permutations and combinations in this way. Permutations. I'll talk about that later, I guess. Combinations, I like to think of it as just a permutation. So this, I like to think of this as 8P3, your regular permutation, and then add an extra step to it by dividing by 3 factorial. That's how I like to think of it. Why 3? Because that's how many items I'm selecting. So combination, again, combinations and permutations are when you have a pool of items you're picking from that you cannot reuse, but it differs from a permutation in that order does not matter.
Professor, yeah.
Yes.
So considering slide 11, if order mattered, like I was wondering, like if the lab question would kind of be specific about it, saying like
decagon, we didn't know order, or are you talking about? Go ahead, I'm sorry. Go ahead.
No, I think maybe a lab question meaning like, yeah, I don't know. Can you go to me? I don't know.
Okay, so yeah, I'll talk about that. Hang on, I'll talk about that more. I'll go over that in just a second. So let me explain this one first about how to find it. First of all, so what do? You do the first you do your regular permutation part, right? I'm picking 3 items, so you're gonna have 3 spots. I'm gonna start with how many options for the first part? It's 8 items, so I'm gonna start with 8, and then go 7, and then 6. Now, because it's a combination, remember my student likes to think of it as being chaos. Chaos, C, is when all of your things you've chosen are all running around like crazy. They're all just jumbled about randomly. Okay, I'm going to have to mute people. Okay, so in other words, let me stop sharing for a second. It's kind of where you pick stuff, and when you pick them, you put them in particular places. Like you go there, you're going to go there. I'm arranging you in specific places, or assigning them something like you're going to do this duty, you're going to do that duty, you're going to do this duty over here, or naming them, right? I'm going to name you Spot. I'm going to name you Fido. I'm going to name you Jasper. That's a permutation. You put them in a particular place, right? Or you've assigned them something. If when you pick them, you're just like, okay, you're in here, you're in here, you're in here, and they're all sort of, should I think of it as, describe it as like you're throwing them into a bin and they're all kind of rolling around in the bin, and it's all chaos, right? It doesn't matter where they go. They're all mixing up, and you can't tell one apart from the other. They're all just in there. Then order doesn't matter. Like chaperones. I pick chaperones. They're all in there. These are all my chaperones, whatever. They're roaming about. I don't care where they walk. They're all in there. But if I'm arranging trophies on a shelf, I want this trophy here, that trophy there, that trophy there, that trophy there. They can't be moving around. Do you see what I'm saying? I'm putting them in a specific position. So when you put them in specific position, then order matters. if you're just picking them to all like videotapes, I'm just picking a bunch of videotapes. And now if I said, I'm going to, how many ways can I pick videotapes and put them in order of when I'm going to watch them, then order would matter. Do you see what I'm saying? Then as I'm putting them in my bag, I'm saying, okay, I'm watching this one first. Okay, I'm watching that one second. Okay, I'm watching this one third. But if I just say, okay, I'm just going to watch, I'm taking these ones home.
Would it go back to the terms from chapter 1? It's fine.
No, it doesn't go back to terms from chapter 1. It doesn't.
Okay.
Has nothing to do with that. It's just about whether or not, whether they're in this bag and they're all jumbled around, and it doesn't matter if they get mixed up. Does it matter if they get mixed up or not? I guess that's the question. Does it matter if they kind of get switched around?
Okay.
And with these VCR things, then it doesn't matter. Right?
Thank you.
You're welcome. But like with top 3 finishers, here's the first place horse, second place horse, and third place horse. Does it matter if I mix them up? And, you know, okay, well, now you're the first place horse, and oh, you're the second place horse. Yeah, it matters, right? If I like someone to be vice president, president, secretary, treasurer, it matters, right? They've been assigned a position. But if I say, oh, you guys are just all in the committee, no assignment, then order doesn't matter. So that's kind of how you can tell. Good. So here is an example we did. So here, how do you know order doesn't matter? It's a little tricky. This is kind of a fuzzy one. But I don't say that they're going in any particular spots. They're just going into the flyer. So here it's going to be, and on the exam I think I'd probably say order doesn't matter. So it's going to be C, 9 items, I'm choosing 4 of them. I'm just choosing them. So this is a choose. So I'm going to do, okay, 4 spots, 4 things. 1, 2, 3, 4. 4 spots make 4 spots. And what am I going to start with? I have how many options for the first spot? 9. I cannot reuse them. So that means I have 8, 7, and 6. Now, because order doesn't matter, that C, chaos, they're all kind of moving around wherever, then I have to divide, then I have to do the extra step. So normally you would just, if order mattered, you'd be done. Piece of cake, all easy. That's the basic one. When order doesn't matter, that's when things, you have that twist. That's when you have chaos, and that's when you have to do the division. I say, oh, 4 items. I'm just going to start here below this one. 1, 2, 3, 4. Just count up. 4. I should end up with this number there. So I divide those out. And then I'm going to say, oh, look. 3 times 2 is 6. 6 over 6 is just 1. Those go away. 4, I can make this a 1 and make this a 2. And then I have 126. So you could do that. Let me clear this. So then your quiz problem was problem number 4. Let's see how people did with that one. I think that was a bit confusing for folks. All right, so yes, so this is the correct answer, which is 10C8. This is not the way you find it, though. Oh, interesting. Yes, so this is it. This is kind of there we go. So it's those numbers divided by those numbers. Maybe I'll draw a line, if you guys are okay with me drawing a line. Hold the shift key down to get a line. So those numbers divided by those numbers, right? You have 8 slots, so it's 10, go all the way down, and then down here it's sort of 8, go down to 1. That's 10C8. Quiz 5, how many ways can you award first, second, and third from a group of 7 contestants? Again, you're going to have 3 slots, because you're awarding three spots. 7 options for the first one, and they get a spot, and then you only have 6 people left for the second slot, and you only have 5 people left for the third slot. 7P3. So this would get full credit. All right. So again, fix your answers if you don't have them down correctly. Let's get Alay. Go ahead and read for us. Oh, hey guys, Angel is here. Let me introduce Angel. Hold on a second real quickly. She will be here. This is Angel. If I can get her on the screen. Angel, say something real quick.
Sorry, I had to mute myself. Did you find me? Or no?
Yeah, I did. Great, thank you. So that's Angel. She is our, everyone say hello. She is our tutor, embedded tutor. She took my class previously, and she did great. Did a really good job of working with people and explaining things to people and working with folks. So she's going to be our embedded tutor for this semester. Not in this class, actually in my 2 o'clock class. So she'll be there from 3 to 4. But you also know a little bit about tutoring, right? So like there's drop-in tutoring, which I emailed everybody about. How does that work? Do you know?
Yeah, I actually do drop-in tutoring right after this from 7 to 9. If you go on Canvas, like on the left-hand side, there's LPC tutoring/raw or something like that. And if you click on that link, you can see what subjects are being tutored. You click on whichever one it is that you need. I tutor math, so if you click on math, you'll see one-on-one rooms and whoever's tutoring at that time and what subjects they tutor. Some tutors only tutor in one subject, others do multiple. But yeah, you get a copy of whatever we talked about emailed to you at the email address that you register with. And we use a whiteboard similar to Jamboard, but it's called GoBoard. And that everything that you put on there will be emailed to you.
Cool. So they get, is it one-on-one, or do they have to wait? Like if they want you and you have somebody already in there, they just wait outside your room or something like that? Or do you take?
Yeah.
Okay. So people can't come in pairs and say, I want to work, the two of us want to work together. Or they could, I guess, but.
I think that would have to be in like a group tutoring room, which we haven't talked about yet. We've only been doing one-on-one tutoring, but I'm sure that there's a way for them to do like multiple people in a session.
Okay, sounds good. Someone was asking about that earlier about like, do they just wait outside and then when you're done, you move on to the next person? I guess that's how it works.
Yeah.
Okay, so they can't sign up ahead of time. It's just drop-in.
So like they enter the waiting room.
Okay.
And then they'll see if someone's already ahead of them, they just have to hang out in there. And if no one's ahead of them, then they actually end up entering the room. But yeah, no one goes to drop-in tutoring. I sat there for 4 hours by myself this weekend, so if you guys need help, please drop in. I'll be there from 7 to 9 today, and Thursday you guys have tests, so you won't need help. But yeah, I'm there. And tutoring's available until like 10 p.m. and it's Saturdays, Sundays, like any day that you need help.
That's super awesome. A good deal. So 7 to 9, I'll send people to you. Perfect. That's great. So after class, you guys totally just hop in there, and Angel can help you with any questions you have. She knows me. You know, she has had me before, so she knows all my weird things of how I want things. So that's good. Great. How do you know when it is a combination? Why am I reading this? Alay, did I have you read already? Nancy.
No, you did.
Oh yeah, go ahead.
Okay, so how do you know when it is a permutation/combination? When you have one pool of items you're picking from and cannot use your items or reuse items. And then how do you know when it's a permutation versus combination? When you select each one, are you putting it in a specific place or assigning something to it? Or is it just going into a giant bin or mixing with other bins?
Great. So it's kind of the way of sorting out those two differences. I think it's kind of it just kind of repeats that. So that is it. That's our review of chapter 4.4. Now we're going to talk about previous stuff, multiplication rules and conditional probability. So you guys remember this part here in blue. Let's get Serena. Can you read this for us? So just the box in blue.
P of
Probability of
probability of A and B equals probability of A times probability of B independent.
Okay.
Probability of A and B equals probability of A times probability B. What is that again?
Given.
Given A dependent.
Good. All right. So this is also another way of checking to see if two things are independent. If the probability of A and B is equal to the probability of A times probability of B, then it's independent. If these two things are not equal, then they're not independent, they're dependent. So that's the third way of checking. So for example, here we have here we have a table, and let's see, I want to draw a tree for this. So first, I want to say yellow and male. So let's say we want to know the probability of, I don't know, yellow, male given yellow. We could do that one. Yellow given male. So I would say, if we're going to yellow given male, then it would be, here's my male, option male or female. And how many are male? Let's see. There are 12 males out of 20. So let me use my text box here. So the probability of picking male would be 12 out of 20. Probability of picking a female, 8 out of 20. Everybody on board with that part? Now, say I've done that, and say I went to the male spot. I'm here. Now, what are my options? Well, I could have, it's a male puppy, given, now, if I'm here, then I know that male has happened. I have a male puppy. Everybody on board with me? If I'm standing here, definitely 100%, my puppy's male. Now, it could be a chocolate lab, a black lab, or a yellow lab. Chocolate, black, or yellow. What's the probability it's chocolate? Well, let's see, I have 12 puppies that are male. So given is the only time when you're not out of everybody. Now, given it's male, I know it's only going to be out of these 12 puppies. There are 5 out of 12 that are chocolate. There are 3 out of 12 that are black, 4 out of 12 that are yellow. So I can type those on there. Chocolate was 5 out of 12. Black puppies, there are 3 out of 12 that are black labs, they're male, and then out of the male labs, 4 out of 12 are yellow. Okay? I can do the same thing down below. Again, I'll have chocolate, black, female. Jack, chocolate, black, and yellow. Female labs. And my question is are yellow and male independent? So what I'm going to compare here is the yellow, let's see, yellow males. Yellow males, I want to see if the probability of male and yellow, equals the probability of male times the probability of yellow. So here I'd say, okay, probability of male and yellow. I have 4 male yellow puppies out of 20. That's pretty straightforward. So it really does 4 out of 20 equal, let's see, probably male. There are 12 males out of 20. 12 out of 20 times yellow. There are 6 yellow puppies out of 20, so 6 out of 20. And the answer is no. That means it is dependent. If these two numbers are not equal, it's dependent. So that's the first way of checking for that's an extra way of checking for independence. If the probability of male and yellow is equal to the probability of male times the probability of yellow, then they're independent, because it goes back to that's the condition for them to be independent. It has to follow that law. This one does not. So they cannot be independent. They must be dependent. The other thing I want you to notice, so then what it would be it follow that second rule, which is true for everybody, which is the probability of male and yellow should equal the probability of male, 12 over 20, times let's see, we said yellow, that'd be down here, so that'd be 4 over 12, times 4 over 12. And the beautiful thing you'll see, which always works every single time, is that these two things cancel out. This 12 over 12 cancels out. And I'm just left with 4 over 20, which is exactly what it is. That's the probability of male and yellow. We also call this the probability, if I said the probability of yellow given male means we are here at this spot. So what's the probability of yellow given I'm standing right here? What's the probability that I have a yellow puppy? Anybody?
Is it 4
4 out of 12, exactly.
12?
4 out of 12. It's just that simple. We'll go over more of that in the next half hour. The other thing I wanted to point out was the other way you can find if they're independent or dependent. People are going to need to know this. Yellow male. Let's see. Find my total yellows, total males, total yellows, and total yellow males, and my total. That is 20. And then see if those proportions are the same. So the question is, does 4 over 6, right? 4 over 6 equal these guys, 12 over 20. 12 over 20. That's the other way we went over before, and that is no. So that means they're dependent. That is probably the easiest way for you guys to do this problem on the exam. That's
Professor
one.
Young?
Yes.
This has nothing to do with B given A, or?
No, well, that's another way of doing it. It is. So this is the same thing as this. So the third way is the first way we kind of learned it was there's a probability of male equal the probability of male given yellow. And that's exactly what these are. This is just an easy way of finding that. What's the probability of male? What's the probability of male? 12 over 20. That's this one right there. What's the probability of male given yellow? Given yellow, probability of male is 4 over 6. That's this one right there.
Okay.
Does that make sense? So yes, they are, that is the same thing. It's just this is the shortcut, easy way of finding those, is using this kind of this box, this rectangle of finding these 4 things and putting one over the other one.
And are you gonna give any hints, like will the test have like boxes like those, or will you probably do like maybe like data sets that we'd have to look through?
You're gonna get this exactly like this.
Okay.
You will have to fill in these numbers here on your, I'll ask you to fill those in and type them in, and then I'll ask you questions about the probabilities.
Thank you.
You're welcome. Good questions. All right, so I want you guys now just do some work. Do problem 16 on your worksheet. So guys, listen up, focus. I want you guys to do this. Make the first, draw a tree, make the first layer of branches risk. So, insurance company has low risk, medium risk, and high risk drivers. How many options do you have for risk? How many options are there? 3. So you're gonna have, you'll have just like this, right? Low, medium, and high. That's your first part, and then you got to figure out the probabilities that go on each of these branches. Instead of the percents, give me them as decimals. It will make your life way easier. Anytime you're going to be multiplying or adding or anything else, change your percents to decimals. So 60% is just like 60 cents. 60% equals 60 cents. How do you write 60 cents? 0.6, oops, sorry, 60 cents, just like that, right? So just write it just like that instead. Make sense? Everybody good with that part? And then, after that, you have to figure out, well, what do you know about each one of these things? What else do you know? You know that 1% of the low-risk drivers had an accident. 5% of the medium-risk drivers had an accident. Well, if 1% of drivers had an accident, what do I know? Either you had an accident or what?
Or you didn't.
Or you don't, exactly. If 1% have an accident, then what percent don't? You guys should be able to figure that out too. So I'm going to go and open up the rooms. Just do problem 16. If you finish it, you can move on to the next one. But let's just try to get you through this one pretty quickly. 5 minutes, ideally. Brenda, what room are you in? Grace, are you in 1?
Yeah, well, room 1, sorry.
Oh, you're already in room 1. Sorry. Adriana, where are you supposed to be?
1.
Aiden, you're here. And Colleen, where are you supposed to be?
1.
1? You're in 1? Okay. Guru, what room are you in?
You should be in 4 with me.
4, okay. And you should be in 4 also, right?
Yeah.
Where are you now?
I'm in 7.
7?
Yeah.
Who else is not in the right spot? Anybody else not in the right spot? Okay. Constantine, where are you supposed to be?
Group
10, is that what you said?
9.
9, okay. Malia, where are you supposed to be?
Room 2.
2. Aiden, let me see where you are. Oh, I need to stop this.